Thank you, David. My main contribution has actually been being about 1 hour behind Claes Tingvall the last 25 years. I've learned a lot in that journey, and I have had a lot of fun on the way. I will talk about vehicles, and I will try to give you a brief history of vehicle safety, but especially an outlook to the future. Not in the technical detail of the future vehicles, but what could it actually mean to our societies and to road traffic safety to have automated vehicles. But before doing that, it's always good to show some kind of success. This is a very interesting curve, I think, about the road traffic fatalities in Sweden from 1950 up until today. How we had a peak around 1970, and from that moment we have been very successful in reducing road traffic fatalities. I would say if you plot Australia on top of this, it's a very similar journey, except for the dip in 1967, which Mike Lenny correctly had in his future picture. That was when we started to drive on the right-hand side of the road. It was very efficient for 1 year, traffic safety-wise, but then we were back to normal. I also plotted in Australia and give you the free choice to discuss whether you are higher than us or just a few years after. I prefer to look at countries as being a few years after, which is giving the perspective you can pick up very rapidly because you have the knowledge, you have the solutions, the technology is there. So it's really important to see that you and many other countries should be able to be where Sweden is, not in 50 years, but in 10 or 15 years maximum. Vehicle safety has been a major contributor to this development. This is the relative fatality risk in cars introduced those different years. And if you look at the average in this study, there were cars built in the early 90s. Going back 20 years, they were almost 1.5 times more dangerous. And going to today's numbers, we are at a fraction of the fatality risk in the cars, measured in car-to-car crashes. This is really a success story when it comes to road traffic safety, how technology has supported us in many ways over the years. I will talk more about this lately. But before talking about vehicle safety, I think it's extremely important to understand that vehicles is one of the components in a safe system. They do not work in isolation, and the maximum benefits of good vehicle safety is only available when that is playing well together with the road designs, the speed management, the road users. So a vehicle in itself is not the solution. It is a vehicle which is designed to the system and a system which is designed to the vehicles. Just as Claes showed us earlier, there are ways to build a speed limit system built on modern cars, and we know approximately where that would stand. And just repeating slightly on the Vision Zero, it was decided by the Parliament in Sweden. That was a very important thing. That is not an expert decision. It was a decision made by parliamentarians, and they didn't argue a lot about it. And the main components is the long-time target, no fatality or severe injury. And that is really changing what we do today, knowing where we are heading on the longer term. It was a dramatic change of focus from crashes to the fatalities. And that is really guiding anyone working with traffic safety to know more precisely what is our target. And that is why we heard about the need to also understand the severe injuries, not only the fatalities. For in some cases, the severe injuries do come from different kind of crashes, needing different strategies for prevention. Vision Zero is also the idea that everyone can and should contribute to road traffic safety. It is not a task force solving the problem. It's actually a question which should permeate society a lot more than it has done in the past. And that is also what Claes was talking about, road traffic safety is now a component in health, and health is a component in sustainability. It will help us in the road traffic safety community a lot to understand how to play together with other processes in society. Vision Zero is about building error tolerance. We all make mistakes and misjudgments, and we are not bad people because we do that. We must actually be protected from ourselves. And in the end, mobility will be a function of safety and not the other way, unsafety a result of a too high mobility in society. The ideas were very much encompassed by the European Commission a few years back when they talk about in the year 2050 we should be close to zero. The close to is probably some kind of diplomatic thing to get everyone on board and not talking too much about the last saved life. Sorry. And as Klaus was talking about, it has now been part of the United Nations work to actually say road traffic safety is an element in this. This is a slide I've been showing for many years in relation to the management system standard ISO 39001, that we were really trying to find ways and means to find the element of road traffic safety in different processes, in different organizations, in different companies. Instead of saying, as in the lower here, traffic safety is a process in itself. And that's what the UN has now also decided to be the way forward, looking at road traffic safety in other things, such as traffic planning, urban planning, commuting, public transport, everything like that. But getting back to the cars, it is amazing to see how we have reduced fatality risk with around 85% over 30 years. And it's worthwhile to reflect, where does that come from? Because there have, of course, been different driving forces behind this. Going back to the 60s, it wasn't a lot of focus on vehicle safety. Ralph Nader wrote the book Unsafe at Any Speed in 1964, in a way starting the whole game that vehicle industry should and could take some responsibility in protecting their consumers. And that's an interesting thing in industry. They cannot consider their consumers being stupid, bad people when they get hurt. As a manufacturer, you must love your customer, otherwise your relation will not be very good. So they have been extremely good at developing their cars. This is just a series of Volvo cars from the early 60s until today. And if we would start to analyze the safety level in each of these, you would see a similar step towards higher and higher safety. But I will talk about four main and big things. One is the focus in industry, about the new car assessment programs, about stability control, and about seatbelt reminders. In our early days class, we did this Folksam car model safety rating, and the recommendation in the report was already at that time, if everyone just picked the right one, we could reduce fatality risks with 50%. Not changing size, not really introducing new technology, just picking the better of the options in a vehicle size class. And this was fairly big news in society at the time, that the safety differences were so big. Going from the worst car to the best car would diminish your risk with 70–80%. And going the other way around, from the best car to the worst, would fourfold your risk of a fatality in that car. So I would say these studies and other studies showed the huge differences in the car fleet and started industry to actually not only saying we deliver safety, but also delivering proper safety. Because they knew sooner or later, some researcher somewhere in the world would actually assess what they have done. The problem with retrospective studies is, of course, it takes a long time to evaluate and understand the differences. So quite often the vehicle model that were under study had disappeared from the market before we knew the safety level of it. And that is why in the mid-90s it was a big development around the world of crash test programs, trying to the best of our knowledge to identify the safety level of vehicles before they were put in traffic. That is why it's called new car assessment programs and not second-hand programs. And the Euro NCAP program, which I've been active in, has shown to deliver very, very well. These are Swedish studies showing that if we look at the relative risk at the different star levels and looking at fatal injuries, the worst outcome in a crash, the relative risk goes from over 1 at a 2-star car to 0.3 in a 5-star car. So these are again cars from approximately the same time, but delivering very, very different safety performance to the drivers and passengers. Almost a 70% risk reduction going from a 2-star car to a 5-star car. And that is amazing, I would say. It's showing how regulation has pushed up the safety level only to a certain amount. And over and beyond that, it is industry competition. Because remember, it's not Euro NCAP or Australian NCAP delivering the safety. It is industry delivering the safety. We are just helping them to focus the most important safety areas. And we are benefiting from this in everyday traffic. I can see in my country how we save 7, 8, 10 more lives per year just in the exchange of vehicles. And we are at around the same levels as Victoria, 260 last year. Another very, very big thing that happened in 10 years' time was the introduction of electronic stability control. Cars lose control and they crash. That's a fairly common thing. And in Sweden, with bad weather and snow, it's getting even more complicated. And the almost aesthetical photograph here is from a Swiss policeman taking beautiful photographs of crashed cars. But a very typical situation: wet weather, loss of control, and a light pole too close to the road. Completely fatal outcome immediately. That can virtually be eliminated with electronic stability control. The different dots and estimates here are all from different studies looking at all the elements from all crashes in society with any kind of injury down to loss of control crashes with fatal outcome. And the last estimate we have in Sweden, which is fatal loss of control crashes, the ESC systems are taking 97.5% of these out. It's just astonishing numbers, how a technical system virtually can eliminate loss of control. And that is, of course, influencing how we design roads. The need for some protective areas around the road is diminishing when you have good safety in the vehicle. But loss of control is not the only reason why we leave the road, so it's still good reason to have median dividers and guardrails. But it's showing how technology can virtually eliminate some of the crash types we have been used to. Another thing, seatbelts. That's Miss Sweden of 1959, putting her seatbelt on in a Volvo. We know that they reduce fatality risk with around 50%. But when we started to more in detail study fatal crashes, we saw that around half of the people in the crashes were unbelted. Roadside studies showed more than 90% having their belts. So when you really needed the seatbelt, it was not everyone putting it on. So we started a working group and had big discussions with industry and suppliers in Sweden. What could we do about this? With only half of the people protected by the seatbelt, should we go the American way and design cars for unbelted people? Or should we go the European way and get people belted, but this time properly? And what we came up with was the seatbelt reminder as you see it today. Being quite noisy if you forget about your seatbelt, but it has a very high efficiency in getting people belted. It came into Euro NCAP in 2003. It came into Japanese regulation in 2005. It came into European regulation around 2013. And now I think it's part of the global regulation, so any country can use it. And I must admit, it's quite fun to get into a taxi car here in Melbourne late at night and seeing it has even the rear seat monitoring of seatbelt use. And knowing that was something I was soldering in my basement with my then 2-year-old son in my knee. He's now 22, and it's some kind of a thing we have left after us, me and my son. Now I did something wrong. There we are. And the effectiveness, roadside studies around Europe is showing that the systems are taking about 80% of the non-usage out of traffic. 80% of non-use is taken away out of traffic, virtually independent on where you started. Some cities started at 70% and came up to over 90%. Paris, surprise, surprise, had the highest seatbelt use in Europe in this study, but also there, about 90% of the non-usage disappeared in cars with seatbelt reminders. And the amazing thing is that it's showing about the same effect in fatal crashes. Not many systems show the same effect in everyday traffic and in fatal crashes. Extremely successful for mankind to actually save lives by seatbelt reminders. The problem, though, it doesn't happen overnight. Often we say that the fleet is so old you will never see the effect. But even if we only have 7-8% exchange of vehicle fleet every year, it doesn't take enormous time to influence a significant part of the driving distance. If we look at our numbers in Sweden, 75% of the car's driving distance is done in under 10 years. So the last 10 years when they are living, they're not driven very much. And this makes it possible for us to actually make a prognosis what will be the effect of this also in the near future or a few years ahead. And we have more things coming. Vehicle safety and new modern technology is a great fun area to work in because you see new possibilities coming virtually every year. We have the speed assistance systems coming out now in more and more cars, telling you the speed limit, beeping at you if you go too fast, and even in some of the most modern cars, putting your adaptive cruise control at the speed limit of the spot you're in, making your driving very, very comfortable with the car supporting you in how you actually drive speed-wise. You have all the autonomous emergency braking, camera-based, radar-based, helping the driver to avoid some of the crashes. We have lane departure systems. Preliminary results from Sweden show that they take at least 20% of the drift out of your lane crashes away, probably a lot more. We have adaptive cruise control. So we see cars developing very, very rapidly. And we also, when we make a prognosis of future fatalities in vehicles, this is 2002 real outcome, 2010 real outcome, and our prediction for 2020. And the blue dot is the situation as of last year. So we are rapidly approaching the situation where in-car fatalities on Swedish road with our infrastructure is becoming less and less of an issue. And if you look at this graph, the blue is in-car fatalities and the red is the vulnerable road users. They will cross this year or next year, showing that the strategies we have for vehicles, for roads, and for speed limits is really paying off for people in cars. But the focus will have to be a lot more in the urban setting. And that is why what Claes presented earlier today becomes so important. How do we build livable, positive cities where the injuries to pedestrians, bicyclists are at a different level, where security is at a level where we can accept and like to be there and live there. So this is our challenge, I would say, to build a more social, more inclusive city where the gap between the car users and the unprotected road users are not as big as they are today. And from my observations of Melbourne's limited they may be, here you have more of a car-centric society compared to Stockholm, if you would go there, where it's a better balance, where it's more positive. And actually, the interactions are not as full of conflict as I could see in some places here. So it's really a question, what kind of society do we want? This intersection is actually from the program of this conference. Is that the kind of societies we want? Gothenburg up to the right, Stockholm down. As Claes said, 60% of the surface is infrastructure for cars. I'm not certain that this is the kind of cities my children want to live in. So vehicle safety is influencing a lot more than we believe, and I think we must now start to look at the system, at the performance of today's vehicles. What could be changed for higher mobility? What should be changed for lower mobility? And how could we have a more livable city? But the safety development has actually had another side effect, which is the situational awareness. The most modern cars have radars, they have cameras, they have ultrasonic sensors, so they know what's around them. And some of them is used to protect the unprotected road users, pedestrians and bicyclists. But they're building a primitive awareness. And then, of course, the step to thinking automated cars isn't a very big step. So that has happened, and you've heard all about automated car. We had it up here already in the discussion as a remedy for virtually everything, but there are technical challenges, and I'm not the engineer to talk about technical challenges in automated cars. It's a huge step to go from a system that is active twice in the lifetime of a car to a system like an airbag, one time perhaps, or an autonomous emergency braking, to a system which should work all the time and supporting you all the time. But I'm certain technology will be there. And I'm certain that these new cars will have safety as a limiting factor. We will demand a lot more of an automated car compared to a driver-driven car. That's logical because we are no longer agents. There are no longer drivers we can blame. It is technology. And we will get to a new technological safety level. During this seminar, I just Googled safety of elevators. Can anyone have a guess on the amount of billion elevator trips in US? It's something like 60 billion elevator trips per year in US. And the number of fatalities? 27. It's an automated system which has had safety as a paramount demand all the time. And that is what we will see for automated cars as well. Safety will be the limiting factor for these automated cars. So they will be careful. They will be utterly careful, almost to the level where they are inefficient, because they cannot expect people to be as logical as they are. They will be polite. They will be law-abiding. Already that is a huge benefit for safety. So I think they will become almost a social creature. I have a robot vacuum cleaner which's got a name. It's almost like our pet. And it's traveling around doing us a lot of services in a very friendly way. So safety will become a prerequisite for mobility, as we have in all other systems except for cars. How many hours haven't we spent together in the queue at an airport for a virtually non-existing risk? We accept it with a smile, and we're even happy for them to take care of the safety level. That will be the same in traffic. We will actually say safety comes first. And that's the same for trains, but it has not been the same for vehicles, but it's becoming there. And the example here is from a modern Swedish road where actually mistakes do not lead to fatalities. Dents in your car, holes in your wallet, but doesn't cost you your life or your long-term health. And we know also that uncertainty and safety can be compensated by low speeds all the time. The higher speed you go, the better your environmental knowledge must be. Down here you can see the sensors of a modern Mercedes car which could go almost automatic full speed. It's looking several hundred meters ahead of the vehicle. And that is becoming complicated, but could be, if you go to low speed, something completely different. That is where connectivity comes into play. How do cars communicate with one another? The lower picture here, two cars heading for a head-on collision. If I'm automated and I send a message to the other car and I doesn't get a response, for safety reasons, I will probably have to park until we have met and then continue again. So communication and connectivity will be key. As we said, parked cars is not a really good idea. So the question is really, what will automation be in the future? Will it be the same city with the same transport and the same cars being used 2% of the time? I do not think so. I think there will be a different kind of transport system in those cities. It will be automated cars, pedestrians, bicyclists meeting on a shared space, what Klaus had on his slide, 20 kilometers an hour streets, which is about the average speed in traffic here anyway. It doesn't really change a lot to what you have. So what I foresee are those low-speed pod cars that will be part of public transport, first mile, last mile thing, low-speed cars to distribute goods and services. The small one down to the right is a prototype about the size of a robot grass mover, giving your deliveries. Because that's what we expect. They can do that in mixed traffic with pedestrians and bicycles because they are slow. They can stop in a meter or even 30 centimeters. Don't start with very high speeds. And the map in the middle is really how could a bus system look when you have assistance the last and the first mile of your journey? Could we have subway stops further apart, giving the high-speed transit more priority because we support the shorter distances by walking, biking, or for those who need it, automated cars. So there are a couple of really exciting questions, and one of them is the cost of journey, something which will change. We say now journey time is cost to society. If you're automated, it's not a cost. You can do other meaningful things. Would change completely any planning pattern we have. Will they change ownership patterns? Will it be a shared economy where you don't own your car, you buy the transport service? Will the safety package for the automated cars move over to all other cars, giving also manual cars or cars driven in manual a lot higher safety? Will they be full speed everywhere all the time, or will there be another introduction strategy, which I believe? Will they start to really cooperate? How will industry now meet us as infrastructure providers and ask, for our cars to be efficient, you need to do more with infrastructure? How will they work together with public transport and logistics? And also in our perspective as infrastructure provider, could we use them to paint the lanes, clean the signs, doing all the small maintenance that we now have people and big heavy trucks out there doing? So there's a lot of exciting possibilities that we look ahead at. Thank you.
Swedish people believe that the Vision Zero has been very effective in making things better in your country, yet your improvement since 1997 is really no better than anybody else's. Your reduction in fatality rates is about 57%, Victoria's 55%, the OECD as a community about 53%. That would seem to indicate that if there is an effect of your Vision Zero, it's not very great. Would you like to comment?
Well, I think you must bear in mind that we started from one of the best countries in the world. So the speed of progression is not necessarily the best way to measure it. But of course, many other countries have picked up similar strategies. Many of the components, like the vehicle safety, has been developed for everyone. So we're not that unique, but I think we have been slightly better in being innovative, opening up new strategy arenas, which is not immediately seen, but I'm certain will show up in the longer term. But I agree, if you look at the patterns generally, The speed of reduction is similar in many countries, except for US, which is slower. And we are not unique, I would say, in that way, but slightly more innovative. And that comes from setting a very tight target, because we know we need to save another 30 lives per year from a smaller and smaller pool of lives. So we have to be smarter, quicker, and more innovative than others perhaps believe they have to be. But we're not perfect in any way.
Perhaps a question right up the back.
Mary Lydon from ARRB. I wonder, Anders, if you could make a couple of comments on the difference of the speed of penetration of technology in Sweden and Australia. I know that things like stability control, autonomous braking are getting into your fleet at a much higher rate. And secondly, if you've got time, it's interesting we talk about seatbelt warning devices. What's the role for seatbelt interlocks and alcohol interlocks, etc.?
Starting with the introduction speed of new technology, we've been very lucky in getting our importers on board and our journalists on board very early. And unfortunately, I don't know your culture good enough to understand why Australia sometimes have been so far behind. We went from virtually 0 to 70% stability control in a year and a half. That's without any competition in the world, very rapidly. And that came from basic research, outreach to journalists and to the population, and a good relation with our importers. And of course, having at the time 2 very safety-conscious vehicle manufacturers in our country. That helped tremendously. But we've seen the same for ABS on motorcycles, good communication and outreach to the motorcycle associations and importers, and in a way, gentleman's agreement, ABS should be standard on every new motorcycle, made it go to 70% in a year or 2. Amazing. And then regulation is coming afterwards, cleaning it up. So outreach, I think, has been our tool. Interlocks, which is not making it possible to drive the car without the seatbelt, was tried in US 1973. And all potential negative side effects of that interlock was immediately discussed, debated, and those systems were prohibited in US for 30 years. That's why when we reopened the question, everyone thought we were complete idiots, which we are, but that's kind of fun. But then we decided to take the track of reminders, because in the end of the day, you have people forgetting about their seatbelt. That's one big group. And then you have groups that don't want to use their seatbelt, and that group is minuscule. And trying to force the last 0.5% by technology is just not a clever thing to do. They will spend their time and money on disconnecting the system anyway. So that's why we found reminders to be a good balance between those 2 groups, because we didn't want people to fiddle around with the buckets, with the electronics of the car, etc. Alcohol starter interlocks is something completely different, because that's a person that under influence probably doesn't have the brain to not drive. But in a sober state, probably says, it's good that this technology is helping me when I'm beside myself. So there I think it has a bigger role to play. But it is challenging in a modern car to add an interlock into the system. That is why we are supporting ISO in trying to develop a standard for a standard interface for alcohol interlocks to be integrated in modern cars, because it is not trivial to stop a modern car, as it was in the past.
Thank you very much.
Please join me in thanking Anders.